Okay, guys, this is 11.4 volume of pyramids and cylinders. So here we go. Some definition postulates on the top here. The volume of a cube is the length of its side cubed. So volume equals S cubed. That works if it's a perfect cube. Postulate 28, if two polyhedra, it's plural for polyhedron, are congruent, then they have the same volume. Makes sense. Volume addition postulate, the volume of a solid is the sum of the volumes of its non-overlapping parts. That's what allows us to find maybe a sphere sitting on top of a cube. You can add the volume of the cube plus the volume of the sphere and the volume of the total shape. Cavalieri's principle is interesting. It's if two solids have the same height and same cross-sectional area at every level, then they have the same volume. That's what allows us to say that if you go back a little bit here, let's go find it. Go back. I had a picture earlier. Get there. There it is. So, if you had like this shape right here, whether it's slanted like this or straight up and down, if it's a right prism or not, oblique, it doesn't matter. If at every cross section the area is the same, Cavalieri's principle says this would be the same volume as one that looks like this but is straight up and down. So that's what he's saying with that. So we can find our place back here. But the idea is kind of, if you think of a prism like a deck of cards being stacked up, or a cylinder is a bunch of cup holders being stacked up all the same size, like those slices, if those are the same, like if you took you could try it at home, take all your cup holders and stack up 6 or 8 of them, and then kind of take and stack them up so that they're not just directly one on top of the other. It doesn't change the volume of that shape, even though you shift each of those over. You still have the same number of coasters or cup holders stacked up, even though they're slanted, looking like that picture I just showed you. Volume. This is something that's interesting. The volume of a prism or cylinder is just the base area times the height. So it's like a stack of cards or stack of coasters when we get to the cylinder, where B is the base area and H is the height. Volume is actually easier to calculate than the surface area. The surface area is the harder of the two. So we'll move through this pretty quickly. It's not too hard. Find the volume of the following objects. So here we go. You almost want to think of this shape right here as, I can't stack it on its actual base, but its base is the triangle, not the rectangles. We do have markings that say it's congruent. So we've got an equilateral triangle. So I'm going to write down my volume. Volume equals big B times H. And I'm going to just replace big B with the area formula for an equilateral triangle, which is 1/4 S squared root 3 times H. So in this case, let's see if do I have my S, 1/4 S, side length is 3, so yeah, I've got it, root 3, and then my height ends up being that 5. I know it looks like a depth, but the height is 5. You got to take this shape and picture it as being sitting on this front face, and so you got a bunch of triangles stacked up to a height of 5 feet. So this is my volume. It's cubic unit. 3 squared is 9. 9 times 5 is 45. We've got 45 over 4 root 3 feet cubed. It's like little 1 foot by 1 foot by 1 foot cubes that would fill that in. Cylinder, same deal, same formula. Different base area. The formula is pi r squared h. So this cylinder has a volume equal to pi 3 squared times the height of 4. So volume equals 9 times 4 is 36 pi cubic feet. So super easy formula to use. The volume, like I said, is much easier than the surface area. So solve for x in the following problems. This one we're going to be going in the other direction. We've got volume equals s cubed. I'm given that s is actually x, so we have x cubed, and volume is 100. So we put that 100 in for volume, and we end up just taking what's called the cubed root of each side. I'll show you where that is on the calculator. So x equals, if you go to your calculator, You should have a cube root button that differs from different calculators, but mine, it's under the math menu. You might see a second and then a cube root. You're looking for something that looks like number 4 right there. It should have a little 3 up to the left of the radical sign. So cube root of 100, enter, and it's about 4.6. So the side length will be about 4.6 feet. All right, this one we've got volume equals base times height. That's a volume formula for a cylinder. This would be like a big water tank or something. Volume equals base times height. We're gonna plug in pi r squared for base because it's a circular base. Now let's see what we know here. We know the height is 12. We know the volume is 4561 cubic meters. What we don't know is x, which is the radius. So here's what we have so far. We've got some algebra to do. Pull this up here. There's that. There's that. Oops, all that came at once. Okay, so there's what we have so far. I can divide through by 12 pi, so it looks like this. Take this pi and this 12, divide each side by that. So I've got divided by 12 pi. That cancels the 12, cancels the pi. Divide by 12 pi over here. So we've got 4561 over 12 pi equals x squared. And we're going to end up taking the square root of each side. So x equals the square root of that thing right there. So like this, square root of that whole thing. So it equals x. Whatever the square root of that will give us our x. So on my calculator, I'm going to type in square root of 4561 over 12 pi. So we hit second, and then the x squared button, square root 4561 divided by, oops, not times, divided by. And then what we want to do is in parentheses put 12 pi. If you don't put it in parentheses, calculator will think you want to divide by 12 and then multiply by pi, according to the order of operations, and that's not what we mean. We want all of the 12 and the pi to be on the bottom. Enter, and we get about 11. It's about 11. All right. So x is equal to about 11 meters. Okay, so cylindrical shark tank. It could be just like the picture over here. You could actually reuse this picture, just change the dimensions. Use this picture here. So cylindrical shark tank, here it is. Has a diameter of 40 feet. So the diameter, it's all the way across, is 40 feet. And it's 23 inches deep. 23 feet deep. Good luck fitting in there, sharks. 23 feet deep. How many gallons of water are needed to fill the tank? So 1 gallon is equal to 0.1337 cubic feet. That's the conversion. We're first going to find the amount of cubic feet. So we got volume equals base times height. So volume equals pi r squared times height. So volume equals pi. The radius is half the diameter. The diameter is 40. The radius is 20. And the height is 23. So that'll give us our volume in cubic feet. It's a big number here. So there we go. Back to the calculator. Second, pi 20 squared times 23. It's about 28,900 and we'll just say 28,903 cubic feet. Cubic feet. So that's what we have so far. So if we have 28,903 cubic feet, and we want to get this in gallons, we need the cubic feet to cancel out. So we need 0.1337 cubic feet on the bottom and 1 gallon on the top here. That's going to cancel out our cubic feet. leaving us with gallons, an incredible number of gallons. So we're going to take that 28,903 number, and yes, we're going to divide it by 0.1337. It's going to be a lot of water. So 216,175 gallons. 216,175 gallons of water. That's a lot of water. Take one milk jug and multiply that by 216,175. So that's a lot of them. Hopefully you're not filling that thing up one milk jug at a time. It'll take a while. All right. Practice problem, a couple practice problems. You're going to get plenty of practice there as you work through the problems in the textbook. So that's it.